Thank you. Thanks. Great. So I'm Chris Butler from Philosophie, Director of AI. I realize that's a very hyped up term and probably title, but then again, I had a Director of Global Mobile Monetization at Kayak, so you can probably tell when I had that job what year. So we're going to be talking about building products with artificial intelligence and machine learning. But probably we should start with what is actually AI in this case, and try to do it in 5 minutes. And what I usually like to do is start with what it is actually not. And so in this case, AI is not just chatbots, although everybody's asked to build them, they will fail at them, and then they'll go off and build something else. It's not magic pixie dust that you just sprinkle on top of a product and hope that it makes it better. It's also probably not going to kill us all anytime soon, or at least in the near term. It's also not something that we're probably going to fall in love with in the near term. And when we talk about the way that it's perceived by a lot of people in the world, if you type in AI into Google image search, this is what you see. A lot of kind of blue glowing brains, a lot of robots with human faces, and that's definitely not what it is today. I mean, this is fancy clip art, but it's definitely not what artificial intelligence is. Getting a little bit more serious, though, it's also not just a term that's called human in the loop, which comes from a military background, but this is an image from Cheng Hao Tan, who was talking about the idea of not only human in the loop, but machine in the loop. And so what this means is that really the human being is helping the robot or the machine or the algorithm make decisions or approving decisions. But it's not just that. It's not just one machine and one human anymore. It's actually networks of machines and networks of humans in organizations. It's also not another term which is called out of the loop, where machine learning or AI is actually off doing things without human advisors or human impact. And so this is a scene from War Games, and sorry, spoiler alert if you haven't seen it in the last 23 years. This machine, Whopper, is a out-of-the-loop system that tries to start nuclear war until it plays tic-tac-toe with itself, basically. But so there's no such thing as human out of the loop, right? There's always someone that's impacted. There's always someone that in some way is getting the action from the machine learning, taking some type of toll on their life or impact. It's also, when we talk about automation, it's not just about automation from the standpoint that a machine will start to do it. Self-checkout is a great example of where a bunch of companies, and actually corporations are probably the original AI, and I stole that from someone, that's not me. But you know, the concept of self-checkout was really a decision to reduce the number of people that were employed and offload that work onto human beings. None of these systems really offer any type of real automation. There's no AI here. There's barely even voice. So I would just warn that not all automation means that there's actually some intelligence behind it. So what is it? I am not going to go into a lot of depth about the technical sides of this because we're all product people, right? We don't need to be technical. And so I think David Robinson from DataCamp, which is a great way to learn about data science as well. I mean, I think product school probably is doing a great job with that. But he breaks these three topics into basically data science is producing insights, machine learning is producing predictions or classifications, and artificial intelligence is producing actions. And now you're never going to really have one of these things without the other two. Most of the time, whenever systems are built that need to make some type of decision-making capability, they need to also predict things. They also need to understand the world. And so all these things are usually together. And so that's why when we talk about artificial intelligence, we're really talking about data science, machine learning, and artificial intelligence, which we used to call big data, predictive capabilities, and artificial intelligence. And probably what's most important is how do we think about this from a human-centered standpoint, right? Design thinking is getting a lot of lip service and also be called BS at the same time. But when we think about this from a human standpoint, right, it really is a lot about data science providing insights about people, for people. It's about, machine learning is about producing predictions about what people will do or what they'll need. And artificial intelligence is really about taking actions to help people. And that's really what it comes down to, is that artificial intelligence is a machine algorithm that helps us exist towards our purpose and nothing else. So I think that's something that a lot of people forget. But since we're here at ProductCon, I wanted to talk a little bit about maybe what are the things that we need to be concerned about as product people when we consider building systems that include data science, machine learning, and AI. And one of them is that we need to think about success differently. When I was at Kayak, I worked a lot on the mobile side of the business, especially because Kayak was making the transition from being a desktop-first company to a mobile-first company. And what we started to see was that while people were doing more searches overall, they were actually buying just the same amount of travel. And the reason for that ended up being that people don't travel more than they do just because they have a mobile phone. They don't get more time off. They don't have more money necessarily. And so, I think this gets back to when we think a lot about the way that technology is perceived is that we're always trying to maximize things or minimize them down to zero. And this is related to the rule that's referred to as 0, 1, and infinity, which is a rule that was created to think about how you consider what number of items when you're developing something. And so the idea within artificial intelligence tends to be that we want to bring human intervention down to zero. We want to have one unified system, and we want to maximize whatever behavior we're trying to get humans to do. And that's just not correct, though, because humans are not, they don't have infinity amount of time. They don't have an infinity number of resources. And it's referred to within artificial intelligence as the no free lunch theorem. There's always something that you have to optimize for or generalize for. And I think Netflix CEO Reed Hastings said this in a little bit of a jest, but sleep is our main competition for binge watching. And I think the follow-up quote was that, and we're winning. It's definitely, I believe it's in jest, but that's true, right? Like, there's only so much Netflix you can watch in one day, probably. I mean, I hope. And so people like Apple and Google are starting to think about what does this mean to have something closer to what we'll call the middle numbers, right? The idea of very few numbers or few agents ends up being something that is understandable, say, like Newtonian physics, right? The moment you get up into very large numbers, you start to think about masses and bodies of systems that can be generalized in some way. But humans are kind of messy and don't necessarily adhere to that. So we're more about this middle number. What is the right number for us? And I think it gets to something that's used a lot in pharmaceutical industry, which is called the therapeutic index. So for certain types of medications, you try to actually judge how much medication you should give before it becomes toxic, right? And so we've been mostly considering how do we just maximize or minimize without trying to understand what is this kind of therapeutic index correct amount for human beings. And the reason why this is troublesome, especially when we talk about machine learning or AI, is that this is an example of like an optimization function. And so machine learning is essentially trying to take what it understands about the world as a truth, and that's usually labeled data or some type of input from a human being, and then is trying to reduce that error as much as possible. And that's why it learns over time, is it's constantly re-understanding and generalizing the world to be able to reduce that error. And so once you start having machines doing this on a regular basis, that means that if we are trying to get humans to watch Netflix 24 hours a day, machines will try to maximize that, even at the risk of causing harm to the human being, because they don't have that context. So how should we define success? At Philosophie, we do a lot of work as a design consultancy, and we tend to work on things that are incredibly early stage. And so we were working on a particular project for PricewaterhouseCoopers and Google in a particular industry that's referred to as field service operations. And so just very briefly what that means is that field service operations is whenever a field tech needs to go on site to repair something. So you can't take the AC system out of this building and return it to somewhere to be replaced or rebuilt. You actually have to have someone go on site to now look at it and fix it. There's also dispatchers, there's warehouses, there's parts runners, there's all these different people that are all involved in trying to make sure that all of the infrastructure that we have, all the things that we depend on actually keep working. And so when working with PwC or Google, right, Google Work was actually the group that we were talking with a lot, and they wanted to maximize the number of seats, right, the number of seats that are sold for Google. When it came to PwC, and being from a consultancy, I don't think we do this, but we, trying to maximize number of hours or number of people that are utilized by a company. But that actually wouldn't help this particular company. And in this case, for field service operations, it was a gas station repair company. And so one of the things that we did is we sat in their trucks for multiple days. I learned how a gas station electrician works and installs. It ends up being a lot more like IT than we think. I mean, if you look over here, these are all like internet switches to be able to get a gas pump to work. And so by learning about what their real problems were and what made their kind of job more satisfactory, we understood that it wasn't necessarily like number of jobs, it wasn't necessarily time on job. It was more about the idea that whenever someone is not able to get the job done on the first day and they have to go back for a return trip, it actually causes a lot of problems. Not only is the customer not satisfied because they're like, why is this taking so long? The employee has to deal with the customer or the client in that case. But also it's troublesome because sometimes like they have to drive hours to get onto site. And then finally, from a business standpoint, it actually costs them lots of money. So identifying this particular metric was really key to building out the systems that we built. And so we built a lot of things. At first, we thought it was all about the field tech. And so how do we understand how we make their lives easier? But in the end, it was about helping the dispatchers that are trying to prepare work for the field techs that gave us the biggest bang for the buck, or ROI, especially for return trips. So number two, we need to take care in how we build customer mental models. So what that means is we're going to have a lot of Don Norman today. I guess we're all trying to be designers, while designers are all trying to be product people. But Don Norman did some interesting work in the 80s. I mean, he's done lots of great work. But in the 80s, he actually he did a paper on mental models that talked about the usage of calculators. And so how many people here, when they use a calculator, will actually punch the clear button multiple times before they start anything? Okay. And the truth is that probably all of you were using different calculators, right? Some of you were probably using it on your iPhone, some of you using 4-function calculators, some of you maybe even using scientific calculators if you're still nerds. But in the end, like the way that memory works in all of those different calculators is very different. But the truth is that clearing it multiple times was something that we have ritualized to be able to use all calculators. And this gets back to the mental model we created about calculators, not what calculators assume we should do. And so this is a quote from Don Norman. So we must discard our hopes of finding neat and elegant mental models. And this is one of those cases where whenever someone kind of goes off and builds the perfect prototype or the perfect system, doesn't talk to anybody and says, this is going to be the right way to do things, you're probably wrong. And what we need to do is we need to learn to understand the messy, sloppy, incomplete, and indistinct structures that people actually have. Right? We need to understand how people actually think about the world. And in the end, what that means is that our models are not our users' models, right? The old adage of that you are not your user is very true, and this is the reason why. So how do we get at people's mental models, right? Especially when we talk about artificially intelligent systems where whether it's explainable, interpretable, whether it actually makes sense on the decisions it's making, even though I cannot understand the decisions that it's making, that's very key. So one of the things we do is we do a lot of workshopping and exercises with not only our clients, but also their customers. And so that includes things like empathy mapping, personas, even things like card sorts, other conceptual model types of things. But what this is really meant to bring out is this idea of what are the assumptions that a person has about the way the technology works? And then what are the ways that those assumptions actually play out in the real world and how they do their job? And so this is an example of a workshop we use actually around artificial intelligence called, of course, empathy mapping for the machine. You don't have to draw the robot face, that's optional. But it helps. And this is really trying to understand from a 360-degree view, how do people consider how they interact, how the machine actually takes some type of action on the world. How does the machine understand the world? What are regulations it needs to adhere to? And it's in language that doesn't require people to be machine learning or AI experts. The second thing is how do you do prototyping? And so this is one of my favorite videos where the woman is pretending to be a website that is a booking site for a hotel. And they're having a conversation based on the fact that she can only say things that are actually on the web form for that booking site. And what we start to discover is that the actual discussion ends up being very hostile, right? It's almost like, why are you, he's asking, well, I don't know if I need like a conference room yet or what. I just want to get like a bid for a couple rooms. And she's like, enter your name. And so this type of role play prototyping can actually be very effective even when thinking about things like artificial intelligence systems. But it's not just about prototypes, right? Like prototypes are really key, but we're not selling prototypes. Well, maybe we're selling prototypes, but a lot of you are not selling prototypes, right? Like you're trying to sell solutions to people. You're trying to make people better in some way. And so that also includes the idea of research. So prototypes are there really as a symbol. Right? They're there so that you can have that conversation with someone about what they understand about the world or how you would integrate with their life. In this particular case, this is when we were doing the field service operations project, we did a lot of work where we were trying to understand how do they interpret the way these machine learning prediction systems would work, how artificial intelligent agents within the web interface would actually be understood, whether they thought it was doing the right thing. And we ended up affinitizing in a way that I thought was very interesting. And so this vertical line is really from not understanding to understanding, and then it goes from negative sentiment to positive sentiment. And the groupings that are here helped us kind of organize what we need to work on next. And so down here were the things that they didn't understand at all. And so those were clearly things that didn't make sense from a mental model standpoint. It didn't actually solve a problem they needed. Maybe there was like change management that needed to happen. The things in the upper right-hand corner were that they felt really good about it and they understood exactly what was happening. Even if they didn't understand all the intricacies about why a prediction was working, they understood what it was trying to do. And in those cases, that was good, that helped us build confidence in the actual functionality that we'd been prototyping. And then the upper left-hand corner was that they understood what was happening, but they didn't like it. And there are two things to take from that. One is that there were real job security concerns, right? Will I still have a job after the system takes over? But then two, they ended up also being aspects that should not be automated away. So when it came to human-to-human communication, right, it was something that was still very valuable to both people having that type of communication. And so it made us reconsider what actual things we do in this prototype. So the next thing is really how do you build trust with people? And I mean that from a machine standpoint. And this takes me back to a story where a startup I founded called Complete Seating was an open table competitor. And our job was really to make the host live easier, right? We would handle all the software to be able to do dynamic booking. We would organize the dining room. We would do prediction about timing for people leaving their tables. We also did a lot of text messaging to be able to offload some of the work the host had to do to the machine before the guest gets there. And we did a lot of really smart things. I thought we were very smart. But the problem was that in the system we built, and this was an early version of it, we didn't actually build the right type of trust in the progression of how we built things. And so a lot of what we did was recommending tables that you could start to see people at. And what would happen is that just like any new system, there were bugs. It wasn't a majority of the time. It was maybe 1% to 2% of the time we would missuggest something. But at that moment, we had destroyed any trust we had with the host. And so they ended up doing a lot to subvert the system or override it, even though we still were doing recommendations that would save them from a lot of pain. And that was maybe, when I go back and think about it, we should have done something in the reverse way, right? We should have helped them do their job and then helped them avoid errors rather than do their job for them. And so that progression would have built that trust over time rather than trying to take something away from them. And this is very related to a paper that I think is really amazing from 1997 about automation and trust. And this is from Paris Surman, who's a pretty prolific trust and automation writer. And he breaks it down to really 4 types of trust and automation. And so there's use, misuse, disuse, and abuse. And so use just means that there's the correct amount of trust in the system and that people utilize it when they should. Misuse is about the idea that they trust it too much and they utilize the system when they actually shouldn't. So this could be that, say, a self-driving car monitor is not paying attention, right? That would be misuse. It could be that you're applying a particular system to the wrong use case. Disuse ends up being that I do not trust this system at all, so I'm not going to utilize it, or I'm going to break it, or I'm going to turn it off. And I'm never going to turn it on when I actually should. And then finally, abuse, which I think is most interesting, is when the people that are the designers of the system or the creators of the system do not take into account the actual operator's needs or the end human being's needs. And so this gets back to that idea that you really, like, if you're building these types of automated systems without trying to understand the real use case for the people that have to utilize it, you're going to create something that's really bad. And I think a good example of this is there was a great article in, I believe, The Atlantic or The New Yorker, or sorry, The Verge actually, about how people that get Medicare or Medicaid hours or benefits would suddenly get them adjusted based on automated systems. And they would have to take those systems to court up to the state level to be able to just find out that there was a bug in the system, right? And the reason why that happened was because there was, one, no way for the operators that are the benefits providers that are talking to those people to intervene or to disagree. And there's also no way that they took into account the fact that people's benefits that they depended on to live good lives was changing suddenly. And so this is an example from Georgia Tech, where Dr. Ayanna Howard, she's doing a lot of work with robotics and trust. And this robot was created, they created a simulated emergency situation, and then this robot shows up and is supposed to lead people out. But because it's actually a remote controlled robot, they're able to make a lot of mistakes. So in this case, this one just started like going around in the room over and over again, and this person just kept following it. And actually, a majority of the cases, people kept following this robot around, even though it was clearly pointing them in the wrong direction. And so yes, you could say that maybe they didn't have a good enough setup for this, and they were, they did have smoke and they had fire alarms going off. But this is a good example of where maybe a robot is actually overkill for this type of thing, right? Like a robot tends to be cold and calculated, tends to be considered to be non-biased. But the reality is that within emergency situations, we have a problem that people are not freaked out enough, right? That people are not running for the exits when they should be. So this is a good question, is that when you're building these systems, what is the right amount of trust for those systems? And so how do we build those trusts? I think a lot about, so I did a talk about managing product managers, and one of the tools that I use to think about how we understand whether someone is being a good product manager or not is really about how you build trust within your team. And so there's some minimum bar that if you do something below that minimum bar, and this is across many dimensions, right? If you do something below that, you're actually losing the trust of your team. And if you do something above that, you actually are gaining trust with your team. And so there's lots of examples of what losing trust would be, right? So spelling and grammar, because we deal in communication, if you just have bad spelling and grammar, you should just, one, fix that. And then two, it loses trust of the people that are reading your documents. But as you start to get up into these higher levels of things that are above whatever this minimum bar is, making hard decisions, creating alignment, those are things that really are valuable to the team. And I think this is very related to how we think and talk about artificial intelligence or automated systems. So the idea of simple mistakes is something that people are way less to forgive, right? If you're not allowing intervention, there's no state communication. These are all things that if you don't do that, you'll actually be losing trust with the people that are operating your system. And then above that, how interpretable is it? Do you allow expertise to actually be built on the interfaces that you provide rather than just removing expertise? So these are all things that I think are really, really key when it comes to that. And what's related to trust is actually expectations, right? So people come into using a particular system based on the fact that they've used other systems, based on they have some type of job that they need to get done. And so the way I think about this is really how you do MVPs and prototyping. And so this is The Wizard of Oz, which again, spoiler alert, there's a guy behind that curtain. And this is used a lot in MVPs to basically say that there's you create the illusion of a machine being in control, right? There's a facade that is projected to the user that they interact with, and behind that it's actually human beings. And besides the fact that there have been a couple articles that have come out recently saying that AI is really just human beings in the background, this is really valuable because people interpret machine-first interfaces very differently than they interpret human-first interfaces. And the opposite of that is, of course, the concierge, right? So not providing any interface, but really having the person be upfront as part of the interaction can be really valuable to understand not only the problems that you're trying to get at, but it's more about like, do you want to convey the fact that there's actually a personality and a real human being here? And I don't mean just chatbots either, right? Like, I mean like a real human being. But when we talk about automation in these cases, it's what type of tools do you provide to them to be better at their job, essentially. And then the last part about trust that I think is really important to talk about is this idea of accountability. Because if you have performance and you have transparency, that's something that every system should have. But we actually sidestep a lot of this in the tech world when it comes to accountability. And so, let's say that this white car right here was a autonomous vehicle. All right, so everything's okay. It didn't get into an accident. Okay, good. It made its exit. All right, good. So it didn't get into an accident, right? But is it accountable for the accidents that were caused? Right? And that's a really hard question to answer, especially when we talk about people that are building systems, people that are operating systems, and people are interacting with systems. And so it's something that we need to consider as creators of these systems, as product people of these systems. How does accountability actually work, right? And And then this gets to my maybe favorite quote that I use a lot from Turing, which is that if a machine is expected to be infallible, it cannot also be intelligent. And he was actually referring to mathematicians in this case, because what he means by this is that for us to actually act intelligently, we need to try new things, right? We need to think about and imagine the way the world could be. We need to generalize, and we need to try things from there. But the truth is we all make mistakes, and I think that was very true. Most of what you do as a product person, you will be wrong an awful lot. And that's okay, because if you were not wrong enough, you're probably not trying hard enough, right? And so when we talk about artificial intelligence and machine learning systems, it really comes down to how do you make not only the system accountable for the mistakes that it makes, but how do you get people to help and intervene in those mistakes, and then make them understand why the mistakes are happening. So, in conclusion, I really want you to take home 3 things, right? 1, success isn't just about minimizing or maximizing, right? Your KPIs that you end up going against, or your OKRs, are not just about doing something as much as you can or as little as you can. It's somewhere in between. And understanding people and your customers is the way you do that. 2 is that the way you think about things is not the way that your customers think about things. And when we talk about artificial intelligence, it's how are you building systems that fit into the cognitive models that people have that are using your systems. And then finally, we should already be building trust with a lot of our systems, right? But trust becomes even more important as we start to talk about these things like artificial intelligence that are non-deterministic. They'll do things that we can't even understand why they did things. And so that trust ends up being a very key aspect of how you build this. Thank you.